July 9th, 1982. Louis Armstrong New Orleans International Airport, Louisiana, United States. It's raining at the airport, a stormy day in the city of Kenner. Here, Flight 759 departing from Miami is making its first stop. The next will be in Las Vegas, and finally, from there, they will fly to San Diego, California. The aircraft is a 14-year-old Boeing 727-200, built in 1967 and first delivered to National Airlines in 1968. It remained with this company until the merger with Pan Am, where the aircraft took on the name Clipper Defense. On this July 9th in 1982, Flight 759 transported 138 passengers and 7 crew members. The captain was 45-year-old Kenneth McCullers with a total of 11,727 flight hours, 10,595 of which were in 727 aircraft. Alongside him was the 32-year-old co-pilot Donald Pierce with 6,127 hours of experience. The onboard engineer, Leo Noon, was 60 years old with nearly 20,000 hours of flight experience. It's 4 p.m. in Louisiana, and Pan Am Flight 757 is approaching the assigned runway for takeoff. They have received the weather report, which is much better than expected. Earlier in the morning, thunderstorms, icing, and strong winds were forecasted. But the latest report recorded 2 hours ago by the airport indicated scattered clouds and moderate showers. This is the report being distributed to all flights about to take off. It's 4:07 p.m. and the 727 is ready to begin its takeoff. Co-pilot Pierce is at the controls while Captain McCullers supervises and handles the radio. All controls are checked and operational. You can start the takeoff. Roger, establishing takeoff speed. Captain, I need you to activate the windshield wipers.
Positive climb rate.
Landing gear up. Everything seemed to be going well. The aircraft started to ascend, but not even 5 seconds passed before the plane began to sway violently and lose altitude.
Recover it, Don. We're losing altitude.
At that moment, ground proximity alarms began to sound, and the pilots were unable to regain control of the aircraft. The 727 started to scrape against the trees at the end of the airport, still unable to gain altitude, and the next thing it struck was the houses of a nearby neighborhood. After destroying 6 homes, the aircraft's fuel exploded, igniting a large fire that would claim the lives of all people on board. Additionally, 8 people on the ground died in this terrible accident. In one of the destroyed houses, rescue teams found a 16-month-old girl alive. She was in a crib covered in debris, which protected her from the flames, ultimately saving her life. In total, 6 homes were destroyed, 5 more severely damaged, and 153 lives lost. What happened to Pan Am Flight 759? The National Transportation Safety Board, NTSB, determined that the probable cause of the accident was the encounter of the aircraft with a wind shear induced by microbursts during takeoff. This imposed a downdraft and a decreasing headwind. effects that the pilot would have had difficulty recognizing and therefore could not react in time to stop the descent of the aircraft before it impacted the trees. The limited technology capacity at that time also contributed to the accident, as aircraft in 1982 did not have a wind shear detection system like the ones available today. The investigation highlighted that the US government did not provide adequate meteorological information that day and did not maintain wind shear detection devices at the airport. According to witnesses, a wind shear alert was mentioned on the radio frequencies of New Orleans Airport on July 9th before Flight 759 took off. However, the flight crew did not receive this alert. The flight crew had been informed with a recorded weather advisory that was 2 hours old. Despite having a new weather report indicating wind shear outside the airport, there were no procedures in place to inform flight crews of updated weather announcements. As a result of this negligence, millions of dollars were paid as compensation to several families affected by the accident. Three years later, Delta Airlines Flight 191 would crash in a very similar manner, leading to the mandate for the development of a mandatory system in all aircraft capable of detecting and alerting to wind shear near the aircraft. This system was finally implemented in all American aircraft and airports in 1993. A monument to the victims of the accident is located at the Catholic Church of Our Lady of Perpetual Help in Kenner, Louisiana.
Delta 191. You're following a smaller aircraft. Please reduce speed to 180 knots. You're approaching it too fast.
Roger. Reducing speed to 180. A few minutes later, another warning from the controller made them reduce speed again, this time to 150 knots. The aircraft is very close to the airport. While flying at 1,000 feet altitude, they start to enter the thunderstorm they had spotted minutes earlier. That's when the nightmare begins for Flight 191. On August 2nd in 1985, at Fort Lauderdale Hollywood International Airport, United States, Delta Airlines Flight 191, a Lockheed L-1011 TriStar less than 7 years old, is ready to take off. Its final destination is Los Angeles International Airport, but it will first make a stopover in Dallas. The TriStar, commonly known as the Whisper Liner due to its powerful and quiet engines, is statistically one of the safest and most reliable aircraft of its time. At the controls of Flight 191 is the experienced Captain Ted Connors, 57 years old, with over 30 years of experience at Delta and approximately 3,000 hours flying the L-1011. Alongside him is First Officer Ruddy Price, 42 years old, with about 6,000 hours of flight time, and Flight Engineer Nick Nasick, 43 years old. At 2:10 p.m., Delta Airlines flight begins taxiing down the runway. It takes off smoothly and sets course for Dallas-Fort Worth International Airport. It's a hot day, nearing 104 degrees, although there are some localized thunderstorms near the destination airport. At 5:35 p.m., the captain informs the passengers that they will be landing with a delay due to the storms around the Dallas airport, with the first officer at the controls.
Delta 191, cleared to descend to 10,000 feet. We have some intermittent rain near the airport. Winds up to 15 knots, 38 degrees.
I see a storm in our route, and I prefer not to fly through it. Is there any way we can avoid it?
Roger, you can bypass it, heading 010.
The captain gets his way, and the biggest storm on the radar will no longer be an issue for Flight 191. Once they bypass it, they will begin the final descent towards runway 17L. At 5:51 p.m., as the aircraft descends towards the airport, the engineer mentions seeing a cloud releasing rain over the airport in the distance. They don't pay much attention to it and continue their approach. But a few minutes later, it's the captain who alerts the rest of the crew that he doesn't like what he sees. They are approaching a small thunderstorm, and the course they're following to the runway will take them through it.
Delta 191, you're following a smaller aircraft. Please reduce speed to 180 knots. You're approaching it too fast.
Roger, reducing speed to 180.
A few minutes later, another warning from the controller made them reduce speed again, this time to 150 knots. The aircraft is very close to the airport, flying at 1,000 feet altitude, and they start to enter the thunderstorm they had spotted minutes earlier. They've just deployed the landing gear when a strong tailwind pushes them into the clouds. Before they can react, another strong gust sends them downward with brutal force. In the cockpit, only the captain's orders to the first officer can be heard. A few seconds later, they pass through that critical phase of the small storm, but when the co-pilot tries to regain altitude, they are again pushed downwards, this time much more forcefully. They are flying at low speed, and the lift at that moment is practically non-existent. A road and a small field separate them from the runway. They are flying just meters above the ground when another gust tilts the plane to the right, and inevitably, it collides with one of its engines, with a car driving below. The vehicle is completely destroyed, and the person inside dies instantly. Meanwhile, the aircraft, out of control, touches down with the front landing gear, begins to spin, and ultimately hits a large water tank, splitting the aircraft in two. The front part is completely destroyed, while some in the rear section are lucky enough to survive. In total, 136 fatalities and 27 injuries. What had happened? Why couldn't the TriStar overcome that small storm near the airport? After a lengthy investigation, the NTSB determined that the cause of the accident was pilot error combined with extreme meteorological phenomena associated with tailwinds. The lack of onboard devices to detect microburst was also attributed to the accident, as the aircraft's radar only detected thunderstorms. This accident marked a turning point in aviation, as the FAA and the US government decided that significant meteorological events such as microbursts should be detectable by the aircraft before entering a storm. Five years later, in 1990, NASA researchers at the Langley Research Center modified a Boeing 737-200 for in-flight testing. They tested a Doppler weather radar installed on the nose of the aircraft, an infrared device on the sides, and a laser device in the front cargo compartment. Of these devices, only the Doppler radar was effective in detecting microbursts. As a result, this device was installed in many commercial aircraft in the United States, after the FAA ordered that all commercial aircraft have onboard microburst detection systems. Thanks to this radar, hundreds or thousands of deaths like those suffered by the passengers of Delta Airlines Flight 191 have been avoided. 10 years after the accident, survivors and families of the victims gathered in Florida to commemorate the 10th anniversary of the accident. On August 2nd, in 2010, a memorial was installed in honor of the accident victims at Founders Plaza, at Dallas-Fort Worth International Airport, 25 years later. It's been 30 minutes since the Aviaco DC-9 departed from Madrid, and the weather is starting to change as they approach their destination in Granada. The grey day is turning into heavy rain, and the meteorological data they receive indicates that they will soon encounter some gusty winds on their approach to the airport. The pilots switch radio frequencies and begin exchanging data with the controller in the area. March 30th, 1992, Madrid Barajas Airport, Spain. It's 6:00 p.m. in Madrid, and here at gate 231, Aviaco Airline Flight is boarding its final passengers who will depart for Granada in a few minutes. The day is dark, with intermittent rain and gusty winds, causing almost all aircraft to depart with some delay. The aircraft is a DC-932 manufactured by McDonnell Douglas. It's a short to medium range twin-engine passenger plane, produced from 1965 to 1982. It later evolved into a family of aircraft, including the McDonnell Douglas MD-80 and the Boeing 707. The project for this aircraft began in April 1963, with the aim of creating a short-range aircraft to complement the long-range quad-engine DC-8. Unlike its main competitor, the B-727, which used parts from its larger sibling, the B-707, the DC-9 was a completely new design. This DC-9, named Castle of Butrón, was 20 years old at the time of this flight. At the controls of Flight 231 is a 40-year-old captain with a total experience of 10,175 flight hours, accompanied by a first officer whose details are unknown and 3 flight attendants. Additionally, there are 94 passengers on board the DC-9. In total, 99 people aboard Flight 231. Despite being a regional journey, there are 23 Japanese citizens on board and several relatively well-known personalities, including 3 sport journalists covering Granada's team information. Finally, at 7:40 p.m., with a 1-hour delay from the initial schedule, Aviaco Flight 231 began its takeoff roll. They lifted off smoothly and set course for Granada. This journey will be very short, lasting only about 50 minutes. It's 8:15 p.m., and the Aviaco DC-9 is now in its approach phase to Granada Airport. The weather conditions have deteriorated significantly. The grey day has turned into a storm with heavy rain and dangerous gusts of wind that are felt inside the aircraft. Flight 231 is approaching runway number 9 with a tailwind of 11 knots. It's not a very strong wind, but enough to destabilize the aircraft every few seconds as they descend. The aircraft is about to fly over the runway threshold, seconds away from touchdown when the wind unexpectedly changes. The tremendous lateral push they experience causes them to ascend a few meters and rotate almost sideways, practically tipping over to one side just as they were about to land. At such a low speed, the aircraft seemed like a puppet being moved at the whim of the gusty wind. The captain doesn't see a possible go-around and responds by leveling the DC-9 as best as he can. Once achieved, he begins to push the controls to descend against the wind's will. The aircraft approaches the runway dangerously. The captain now pulls the controls to touch down on the ground, doing so very abruptly to counteract their previous movement. Flight 231 goes from descending with a certain degree of inclination to initiating the flare maneuver to try to touch down on the runway with the main landing gear. But the force with which they approach the ground is enormous, and this maneuver, among other things, meant to dissipate this force, only ends up hitting the runway with the tail of the aircraft, and then, almost immediately, with the main landing gear. The impact is so severe that the occupants of the aircraft experience a deceleration close to 5G. The DC-9 bounces against the runway and ascends again. It moves about 350 meters before descending again, this time with both the front and main landing gear touching down simultaneously. Once again, the impact is harsh, subjecting those on board to another deceleration of 4.5 Garai. All the wheels of the landing gear explode, and the aircraft tilts sideways until it promptly splits into 2 massive pieces. The main part advances along the runway, skimming the ground with its wings and generating a large number of sparks, while the rear part comes to a stop after bouncing a couple of times. Rescue teams approach the 2 enormous pieces located in the middle of the runway and see passengers starting to exit through the huge hole that has been exposed after splitting in 2. Some passengers are unaware of what could happen at any moment. The wings are leaking fuel and an explosion is not out of the question. Miraculously, they manage to evacuate the entire aircraft. There are no fatalities, although some are injured to varying degrees. Fate has dictated that the aircraft does not burst into flames despite the sparks generated by the wings and fuselage rubbing against the runway. And thanks to this, all occupants of Aviaco Flight 231 can recount this incredible event, dubbed by many as the Miracle of Granada. What had happened? Were the pilots at fault for this disastrous landing? The investigation, carried out by the Civil Aviation Accident and Incident Investigation Commission of Spain, concluded that the most probable cause of the accident was the adverse weather conditions present during landing, with strong winds causing wind shear and intense rain. The poor weather likely resulted in the aircraft not having a stabilized approach and touching down with excessive force. although some reports also mentioned passenger testimony stating that the crew's maneuvers during landing were not usual.
500.
Iberia, the airline that owns 65% of Aviaco, also initiated an investigation to determine if the accident occurred due to a tire burst upon contact with the runway, which could have triggered the subsequent sequence of events. Following statements from numerous witnesses, the crew requested voluntary alcohol testing to demonstrate their transparency. But this request was denied.
20.
Wind shear can be one of the most dangerous meteorological phenomena for aviation. Between 1964 and 1985, wind shear directly or indirectly caused 26 civil aviation accidents in the United States alone, resulting in 620 fatalities and 200 injuries. Of these accidents, 15 occurred during takeoff, 3 during flight, and 8 during landing. Nowadays, both aircraft and airports are equipped with various sets of anemometers and other technological systems capable of detecting wind shear, such as the LLWAS system or Doppler radars. All these technical aids combined with improved pilot training have contributed to minimizing accidents caused by this factor. The fuselage of the Castle of Butron was removed from Granada Airport and left in a scrapyard until sculptor Eduardo Cajal found it. After purchasing it, he restored it and turned it into a mobile exhibition space, which was presented at the International Contemporary Art Fair of Madrid, ARCO, in 2005 under the name Proyecto Avión. Following its presentation at ARCO, this piece of the aircraft has toured various locations in Spain, transported by truck, including appearances at the Malaga Film Festival in 2007. In 2012, it ventured abroad, being transported by road to Wales for the 2012 Cultural Olympics. It also appeared on the TV show El Hormiguero in 2016. As usual, before signing off, I wanted to express gratitude to all the members of the channel. This week, the new members are Hans de la Torre Roa, Candy, and Mateo Panduro. A big shout out to all of them, and thank you for the support.